Example 1, find dy over dx if y equals e to the 2x. You can do the chain rule or you can use u substitution. So let's use u substitution. I use u substitution. You don't have to. U is 2x, so u prime is 2. I will rewrite this as y equals e to the u. So y prime is the derivative of e to the x is e to the x, but in this case it's e to the u times u prime, which I will go further. So that means u is 2x, so that's 2x, and u prime is 2. I'm going to write the 2 in the front. So 2e to the power of 2x is my final answer for the derivative of y equals e to the 2x. Next, I'm going to give you some more rules, okay? The derivative of a to the x power, and let me give you what a is, where a must be greater than 0 and a cannot be 1, because 1 to anything is 1, so that's not very exciting. So what's the rule? The rules are d over dx of a to the x equals a to the x times natural log of a, okay, if that's starting out as x right away. But sometimes we have chain rule, which we use u substitution. I'm going to highlight all the things that you have to know, okay? The chain rule, sometimes it's a little bit confusing for some of you. So sometimes you're asked to do the derivative of with respect to x, and then you have to substitute u. So how does that look? It's a to the u natural log of a times u prime. So make sure if you're using u substitution, you have to multiply by u derivative. Okay, so here's how we are going to use that rule right away. If I were to go in and say, okay, well, let u be negative x, that means u prime is negative 1. Then I'm going to rewrite this as y equals 9 to the u power. Well, I just wrote down my rule, so y prime is, the rule says a to the x, well, let's use u, a to the u times natural log of a times u prime. I already have everything. A is 9, okay, so I'm going to write 9. U is negative x times the natural log of 9 times u prime, which is negative 1. Then I'm just going to put that negative 1 in the front. So final answer is negative 9 to the negative x times natural log of 9. And box that up. Okay, so our next rule is the natural log of x derivative. So the rule says, with respect to x, natural log of x is, I love this one, is 1 over x. Now, would it be okay if you have u substitution? Of course. So if you have u substitution, then it's 1 over u times u prime. So either one will be fine. And again, make sure you start making a list or flashcards of all of this stuff. Excuse me. Let's do example 3 using that same exact rule that we just got done writing. I'm going to use y prime is, okay, I'm going to use the chain rule. This one looks like I have the power rule. So I'm going to take down the power, which is 2 times natural log of x times the inner component derivative. Well, 2 times natural log of x, the derivative of natural log of x we just got done writing, it's 1 over x. So let's move that to the front. So that's 2 over x times natural log of x, and box that up. We have another rule, which is log base a. Okay, I'm just going to pause for a little bit so you can start writing the question. Writing the work for example 3. All right, so last rule. Ready? The last rule is derivative of log base a. Let me give you the restriction for a. A must be greater than 0, and a can never ever be 1. Okay, So the derivative is d over dx of log base a of x is 1 over x times natural log of a. Box that up, highlight that, because that's what you need to know. Now, how come if some of us like to have u substitution, it's okay too. It's 1 over u times natural log of a, always the train rule says times u prime. So if you use u substitution, don't forget to multiply by the derivative of u. And this is the end of this this video notes. So derivative of log base a of x. So let me give you the rules first. But before I do that, let's give the restriction for a. A must be greater than 0, and a can never ever be 1. Okay, that's just the restriction for the domain of log. So let's start with derivative with respect to x. What if I write log base a of x? Then the derivative of log base a of x is 1 over x times natural log of a. Now, but what if I use u substitution? So the derivative with respect to x, log base a of u, is equal to 1 over u times ln of a, remember a is your base, times u prime. Okay, so keep that in mind. So let's practice. Here we go. 4. Find the derivative with respect to x if y equals log base 5 of square root of x. I'm definitely going to use u substitution. So let u be square root of x. Well, square root of x is x to the 1/2. So u prime, I will use power rule, bring down the 1/2 times x, and 1/2 minus 1 is on negative 1/2. Okay, so that's what u prime is. So here we will now write y equals log base 5 of u. Well, y prime, based on the rule that we have just got done writing, it's going to be 1 over big fraction line u times ln of a, and what is your a in this question? A is 5, and it says times u prime. Okay, so from here we will try to make it a little bit better. So u in this problem is square root of x times ln of 5. U prime in this question is 1/2 x to the negative 1/2. Now let me tell you about x to the negative 1/2. You can make that into a positive power and move it down to the bottom. So 1 over square root of x times ln of 5 times 2 over x to the positive 1/2. Okay, well, positive 1/2 power is really square root, so let's keep on going a little bit more. So x, square root of x times ln of 5, square root of x times ln of 5 times 1 over 2 square root of x. But as you can see, you can totally simplify square root of x times square root of x. So with that said, it's 1 over 2 square root of x times square root of x. It's x, that is true. But because the original value here cannot be negative, so I'm going to go in and put absolute value around it, and then times ln of 5, and that is your final answer. All right, let's practice some more on dy dx with example 5. So find the derivative with respect to x if y equals natural log of 10 to the x. Okay, and again, we are going to use u substitution. So here we go. Let u be 10 to the x. Then u prime is, okay, so think of it as a to the x. So if you look back to your notes, what is the rule for a to the x? The derivative of a to the x. Look back at your notes. Wasn't the rule said a to the x times ln of a. So that's what we're going to write. U prime is 10 to the x times ln of what? A, right? Okay, perfect. So that's u prime. Now I'm going to rewrite this as y equals ln of u. Hi, Ellie. So now let's take y prime. Do we know the rule for natural log of u? What's the rule for the derivative of natural log of u? Did you say is 1 over u times u prime? Of course, good job. All right, from here, we will continue further. Let's substitute in what u is. So u is 1 over 10 to the x times u prime is 10 to the x times natural log of 10. And I'm just going to make this into a fraction, okay? Because what's happening is I can cancel out my 10 to the x. So when that is canceled, I will just have simply natural log of 10. So that is the derivative of y prime. I'm sorry, I should just say that's the derivative of y, because the derivative of y prime is the second derivative, which is incorrect. So that is just y prime. All right, example 6. I want you to take a minute or a few seconds to try 6. Did you get an answer? It's tricky, right? This looks scary. Look at the power. It's 1 plus square root of x. Okay. Now, this one, even though it looks really scary, but out of all the questions that we have done in this 3.9 section, this one's the easiest one. It looks like it might be an exponential, but it's not an exponential. An exponential means that the exponent has to be a variable. But this one, the exponent, is not a variable. It's just a power. It's a constant. It's just a number. So this one, even though you might want to use one of the rules from this section, you don't have to, because I can just use the power rule. So the power rule said this whole thing's your power, so you bring it down, okay, times x, and then I'm going to subtract 1 from my power. So when I subtract 1 from my power, 1 plus rad 2 minus 1 is just really rad 2, and that's as far as you can go. So when you're doing derivative, especially on the test where like all of them are just going to be together, you have to think, hey, you know what, do I need to use the rules at all, right? Because if it's an exponent, which means the x is in the exponent, okay, then you use the exponential rule. But if the power or the exponent is just a number, then you just do old school, okay? Use a power rule. All right, 7. Last thing in chapter 3. Oh my goodness, here we go. Logarithmic differentiation, okay? Use the technique of logarithmic differentiation to find the derivative of x, the derivative with respect to x, if y equals x to the power of tangent of x, where x is greater than 0. Now, yes, you will totally need to know how to do this. So make sure we follow the steps. So step 1, I'm going to spell everything out because it is quite challenging. Step 1, I'm going to write the equation. Fancy, right? So x to the power of. I'll give me some more space. Okay, so step 1, y equals x to the power of tangent of x. Now for this one, I can't really use my exponent rule, just to keep that in mind, okay? Now, but if I go in, so step 2, I'm going to go in and compose both sides with natural log. Okay, so I'm going to go in. What I do to one side, I will now do it to the other, and then copy down exactly everything that we had in step 1. Step 3, I will now do the derivative on both sides. So I will take the derivative of ln of y. The derivative of ln of y is 1 over y times y prime equals. Now this one is slightly tricky, so you have to be very careful, okay? So the derivative of ln of x to the u power. Okay, so let's think about this for a second. You have to just learn natural log of x to the u, right? So what is the rule for that? Can you go back quickly and tell me? Okay, so first we are going to take the derivative. Now let's talk about what do we do with this in Algebra 2. Okay, let's recall really quick. Can I give you some reminder? Recall. Ln of 5 squared. Remember this in Algebra 2. When you have this in Algebra 2, would you agree that the power in natural log or log becomes multiplication? So this is written as 2 times ln of 5. We can use the same rule here. The exponents in natural log and log, they become multiplication. So this right here becomes this, okay? So that's why we're using log or natural log. So I'm gonna write this instead of a power, I'm gonna write it as a multiplication, just like that. Then if that's a multiplication, I can do the derivative using the power rule. So that's what I would do now on step number 4. I will rewrite this as dy dx because I like to solve for dy dx later. Okay, so the power rule says I need to take the derivative of u times the derivative of v plus the derivative of v times the derivative of times u. U prime times v plus v prime times u. And then from here, we are going to work this out slowly. Okay, so again, this is still 1 over y dy dx, okay, equals. The derivative of tangent is secant square of x times ln of x. The derivative of ln of x is always 1 over x. And then I'm going to multiply by tangent of, oops, I want to write tangent of x, but I just wrote ln of x. Okay, tangent of x. Okay, so remember, keep in mind that I'm trying to solve for dy dx. So I'm going to multiply both sides by y. Okay, so step 6. I will now multiply both sides by y. Okay, so if I multiply both sides by y, this 1 over y dy dx, and then y is over here, so I'm just going to copy everything over again. And if you wanted to, you can also put like this, like that. It's not important, okay? But some of you like that stuff. Okay, so from here, I'm just going to distribute, and guess what? That's it. Step 7. This is now canceling, so here is my final answer. I can distribute the y, so this is just going to maintain this in the front. There's not much you can do with this. So y secant square of x times ln of x plus y tangent of x times divided by x. And that is my answer to the example 7. Okay, so let's just recap really quickly. Using technique of logarithmic differentiation to find the derivative. The most important piece is you always go in and compose natural log, okay? Then another piece that you would need to know is that in natural log and in log, if you have an exponent, and that's the whole reason why we are using natural log or log, is because all the exponents becomes a multiplication. So the reason we want to make it multiplication is so that we can use the product rule. Okay, and that's pretty much the reason why. If we leave it in its original format, which is this right here, you can't really take the derivative. Okay, so that's why we're manipulating natural log to do so. All right, guys, this is the end of all of chapter 3. See you guys next time.